Good morning, everyone. Thank you very much for joining us today for this distinguished lecture on the topic Applying Computational Method in Research by Dr. Shubin Yu. My name is Akiko Ueno, and I am an Associate Professor in Marketing and the Head of Research Cluster for Human Technology and Innovation at the University of Bradford in the UK. Joining me today is Dr. Pandya Frodi, a reader in marketing at Brunel University, London, and Professor Charles Dennis, Professor of Digital Marketing and Consumer Behavior at the Newcastle University in the UK. Together, we will be hosting today's session. It is my pleasure to introduce today's speaker, Dr. Shubin Yu. Shubin Yu, so Dr. Yu is Associate Professor in Digital Communication at BI Norwegian Business School and founder of Generative AI for Research. Dr. Yu's research lies at the intersection of generative AI, consumer technology interaction, and marketing communication. His work explores how generative AI is reshaping communication patterns and influencing human perceptions and behaviors. As a leading voice in the field, he has contributed significantly to advancing our understanding of the role of AI in academic research. Today, Dr. Yu will share his valuable insights on the topic applying computational methods in research, an area on which he has extensive expertise and success. Please join me in warmly welcoming Dr. Shubin Yu, a pioneer in applying emerging technologies to advance research. Dr. Yu, the floor is yours.
Thank you very much. Thank you, Akiko, for inviting me today to give the talk about how to apply computational method in research, especially in the field of marketing. So I will first share my screen. Okay, can you see my screen?
Yes, we can see fine. Thank you.
Great.
Yes,
okay,
it started. Good. We can see now.
Okay, great. So here is my brief introduction. So I'm currently associate professor at BI Norwegian Business School, but I'm actually going to work at HEC Paris in the near future, just in this September, and it will also in the field of marketing. And yeah, this is my dog. Her name is Little Me, so you can see her image everywhere actually on my website. And she's also a big inspiration for many projects of mine, so I will show you later. Yeah. And okay, so let's start. So first, what is computational method? So actually, if we take a look at recent publication in leading marketing journals, we can see a rising trend of the use of computational method. So actually, this kind of method, they try to leverage computational techniques, for example, data mining, AI, or text analytics, to analyze large and unstructured data sets. For example, your social networks, or image, or like text. And these methods enable us to get a better understanding and also a more novel insight that traditional method cannot provide. And why at this moment we need to know, at least to know some basic theory, or some basic understanding of computational method. It is because nowadays, we use TikTok, we use a lot of different kind of social media, and we somehow leave our digital footprint. And this digital footprint can be very variable to study human behavior, and offering unprecedented opportunity for scholars and also researchers to understand better our society and also how we human behave. and also combined with modern, computing power, especially now with the emergence of generative AI. So researchers now can detect hidden pattern that somehow we cannot unveil in the past using, for example, experiments or survey. So that can be really nice for us now to make more high accuracy prediction by using of this unstructured big data. Okay. And there are actually a number of different methods. So like I will give you some examples. So for example, the first one is social network analysis. And then we also have predictive modeling, content analysis of text analytics at scale. So before maybe we want to conduct a content analysis and use human to code the content. But now because we have AI, generative AI, so it makes
different from the
sorry, I cannot hear. Is there a question?
Yes, hear you. No, I think just the mic was you
Okay.
unmuted. Yes.
Yeah,
Oh,
I
So
just
yeah. So if you have question, because I cannot hear clearly, maybe you can type it in the chat or.
yes,
yeah.
if you have any questions, could you type in the chat, please, so I can communicate with Dr. Yu. Thank you.
Yes,
Sorry,
I
Shubin.
did check. Everybody's mic was muted, so it was an extraneous noise.
Okay.
Thank you, Professor Charles.
Thank you.
Sorry about that, Professor. Sorry
No
about
worries.
that.
Yeah. Okay, yeah, let's continue. And then we also have sentiment analysis. Like on social media, if you want to study a particular brand, you want to understand how consumers' preference or their opinion about your brand. So you can conduct a sentiment analysis to see when they talk about your brand, are they happy, are they surprised, or are they angry, right? And then we can also conduct a topic modeling to understand, the topic, the main themes from a large volume of text. So I'll show you in detail here. Maybe the first one is social network analysis. So here is an example. So, the 9/11 hijackers, the terrorist attack. So people, they want to understand, okay, who is the main, like people, like to, that is responsible for this attack. So they actually map the network based on their phone call records from the service provider. So they want to know who is calling whom, right? And in this case, they can actually map the social networks among those attackers, the terrorists. And in this case, you can see there are some key um, attackers that has a lot of communication with different people, right? So in this case, you can identify the key player in a social network, who is the most important player among a different numbers of actors. Okay. Or for example, you can do again a social network analysis combined with textual analysis to map, for example, gain of from. So when they mention a person, who is the other person they somehow mention together with. So in this case, you can actually map the relationship between different characters, right? So for example, here you can see, okay, who is the most important person, right? Who is the most important character in the movie, in the TV series, in the novel, right? And who is the when they mention about that person, who is the person they mention together with. So in this case, you can get a very clear overview of the characters. Or for example, by using the citation, so to understand the citation, so which university cites which university, then you can actually get an overview of the collaboration network. Like for example, this one. So by using the citation data. So they somehow map the collaboration networks of medical research institutes in Australia. So that is some application examples of social network analysis. But of course, you can do much more. For example, you can do by using the social media information, you can actually identify the big influencer. So who is following whom, right? On Twitter or on Instagram, then you can map the key influencer. Okay, and another application of computational method is automatic content analysis or content analysis at scale, right? Or text analytics. So for example, we can use a dictionary-based algorithm to understand, okay, for example, you want to study social media post. So what are they talking about when they are posting something about your brand? So you can use a dictionary approach. So for example, when they talk about your brand, which word they are using. So this is a very like fundamental level of the application of computational methods. Somehow you create a dictionary, and if they mention a certain word, then you give a certain score. So for example, if your dictionary is about sentiment, then for example, your dictionary will have a lot of words about how people express their emotion, like angry, I'm very angry, I'm very happy. So if they have a so if in their social media post they mention something about anger, then you give a score maybe -5, -6. And if they mention something about happiness or enthusiastic, something like that, then you give a score of +1 or +2, right? So in this case, you can build a sentiment metric. So this is the first scenario of text analytics, so dictionary. But this one is very basic, right? So you somehow just use the dictionary. So first you need to create a very big dictionary, or you can use existing dictionary already, for example, this one. However, the problem of this method is that they cannot understand the context. For example, sometimes we try to be ironic. I would say, yeah, I'm very, very happy. But indeed, I try to be ironic, right? But dictionary-based text analytics method, they cannot tell the difference. That's why we have more advanced method, for example, supervised or unsupervised machine learning model, like unsupervised mathematical model, like topic modeling, LDA, that we are going to discuss a little bit later, like how we can apply this model in identify different themes, different topic. Or supervised machine learning, for example, decision trees or naive Bayes, so we can understand, okay, when they talk about this, so we can prepare a data set to train the algorithm to let them understand, okay, when people combine maybe, yeah, I'm very happy. So if they combine yeah and happy, maybe they actually mean they are being ironic, they are not happy. So this kind of supervised machine learning can somehow better than traditional dictionary-based method to somehow review the sentiment of the post. But then, of course, now we have large language model like GPT-4, Claude, Gemini. So they are already pre-trained, so you don't need to train them, and you don't need to have this kind of task-specific training. So it's not like BERT, it's also a large language model, but you need to train it first. This kind of pre-trained large language model can be very effective for us, especially for scholars who do not have previous experience in this kind of algorithm or machine learning approach. It can be very helpful for us to do content analysis at a large scale. I will also show you later how to apply this method to conduct automatic content analysis. Okay, so actually this is a kind of classification of automatic content analysis approaches. So you have counting and dictionary, you have supervised machine learning and unsupervised machine learning. But all I want to say is that actually these are all traditional methods. So for example, nowadays, many scholars say we should not use dictionary approach anymore because they are very preliminary, so they are not very advanced and they cannot really understand the context. And supervised machine learning, you can use if you have a large volume of training set. But now the key, like the most promising method is actually use large language model. Even though maybe 1 year ago, I have some colleagues who wrote a paper about content analysis using large language model. 1.5 years ago, they are still, reviewers were still a little bit like not very comfortable with this method. But now it's actually changing. Many leading scholars, they believe large language model is really the, a very nice and very accurate method to conduct this kind of large scale automatic content analysis. So here are something that you can actually cite if, for example, your reviewer are not comfortable with this method. So there are actually many papers coming out from leading journals like PNAS or Marketing Science. So they actually review that large language model actually outperform humans in text analytics. You can actually do that, right? You can use this method, and they're even better than human. So for example, these three papers, and I will take this as an example so you can see the light color is trend annotator, so they should be very good. And then you have MTurk workers, so they are not professional, they are amateur, but many scholars use MTurk worker to annotate some text, for example. And then we have ChatGPT, and with different temperature. So temperature means if you have a high temperature means that the response from the large language model may not be very consistent. And if you have a very low temperature means it can be more consistent. And we can see the accuracy. Actually, you can see they perform quite well. So ChatGPT actually perform quite well compared with the MTurk worker. You can see here, much higher than the MTurk worker. So if you see these are 5 different tasks. So for 5 different tasks, actually they all perform better than the MTurk worker. And in terms of intercoder agreement, it shows very high intercoder agreement compared with MTurk worker, and similar with trained professional annotators. So it is a very promising result for us that we can be quite comfortable if we are going to adopt this method. Okay, and the next one is topic modeling. So topic modeling, traditionally we use LDA. It is a type of statistical modeling techniques used in the field of natural language processing. So to automatically identify topics present in a large corpus of text. For example, if you collect maybe 500 news articles about Donald Trump, and you want to understand when people mention Donald Trump, what are they talking about? So are they talking about economics? Are they talking about political relationship or the tariffs? So you want to understand the topics when they mention Donald Trump, right? So in this case, you can employ a topic modeling method. So the primary objective is to discover hidden structure or thematic structure in an extensive collection of documents. And it is an unsupervised machine learning algorithm. So they do not require label data for training. So you don't need to prepare a training set already. So you can already use it to let it explore by itself. So for example, you have a lot of raw material, like for example, the news article about Donald Trump. And then you apply topic modeling algorithm like LDA, but you also have other types of algorithm like LSA and MF, and then it will identify several topics. So for example, topic about maybe politics, topic about economics, topic about immigrants, right? So in this case, you can identify the topics that are relevant to the articles that you collected. So apart from LDA, you have other methods, And these methods somehow they are quite similar to each other, but they use slightly different techniques. But I will only focus on LDA today because it is the one of the most widely used algorithm. So it somehow assumes each algorithm is a mixture of small number of topics, and that each word in the document is attributable to one of the document topic. So if a news article talks when they talk about Donald Trump, they talk about several topics. So they assume, okay, in this news article, you have several topics, and each topic should have different word combination. So for example, when they talk about tariffs, then you should have some, for example, about some words about price, about China, about UK, about agreement, about taking advantage, right? So you have certain words that are associated with that topic and certain words associated with another topic. So by extracting all those keywords, you can identify, you can assign an article to a certain topic. So that's actually the mechanism of LDA. It's based on word co-occurrence. So, and how do we conduct LDA? First, we need to, install the package in R, pre-processing, determine and create document term metric because it's based on word co-occurrence that the words are very important. That's why we need to first clean the document, clean the corpus to eliminate or remove unnecessary or irrelevant words. For example, personal pronouns, right? Me, I, you, this should be removed. Or maybe words related to number, they are not really important, right? So you can also remove it. Or stop words, for example, to, go, or like in. So these are not relevant words, not really important, meaningful words. So you should remove this first and create a document term metric and then perform LDA, examine topics, review topic term and things like that. So if you're interested in, you can, Google this term and then there are many videos about how to conduct LDA using R. And these are a very widely used method already. However, they are not very good, LDA are not very good at processing small text data or short text. For example, Twitter data. Because we know Twitter, if you want to post a tweet, you can only post less than 140 words. So because you don't have a lot of words, so it's very difficult to identify the topic with short text. So in this case, actually we can adopt a new method, which is large language model. So large language models are very suitable for short text topic modeling, such as tweet, post, or qualitative answer, and very accurate, and it can even give very simple topic classification and give you a definition and also an example, and can be used as a supplementary method for LDA, but can be a little bit challenging for dataset with a large sample size, as we know that if we are going to use ChatGPT or Claude or Llama, they only allowed you to have a certain limit of input token. Like, for example, you can only, for ChatGPT, I think it's only 12800 token. And for Gemini, it is one of the large language model that enable you to have very large input tokens. So it allow 1 million tokens or 2 million tokens for the Gemini 2.5 Pro. So in this case, it is also good that you can, it is also possible for you to deal with large sample size. But if you want to make it simple, you can also draw a small sample out of the large sample. And here are some very promising research about the effectiveness of using large language model to do topic modeling. And they're really simple to use. I will also show you later. Okay, so how to use APIs or this kind of application to do text analytics. So I will give you 2 examples. So for example, you use large language model to you want to know how consumer feel about grotesque advertising. So you show them 3 grotesque advertisements and ask them to write down their feeling. So you want to know when they write down their feeling, what are they talking about? When they talk about grotesque advertisement, what are they talking about, right? So in this case, you can do a topic modeling actually. And second, imagine you have collected luxury brands' tweets. You want to know whether communicating sustainability on social media can increase social media engagement, the number of likes, retweets, and comments. So first, you need to identify whether the tweet is about sustainability or not. So for example, traditionally, you can use a RA, a research assistant, to label each tweet. Okay, they read the tweet to determine whether it's sustainability related or not sustainability related. But imagine if you have more than 1,000 tweets, then it is very difficult for you to label it, right? It's very costly, and also it will cost a lot of money as well if you want to hire AI to do that. So in this case, you can employ a large language model to label each tree. You give a very clear prompt. Okay, if they talk about this, then it is a sustainability related tree. If they talk about that, then it is a non-sustainability tree, right? So you can use text annotation to do this. Okay, so I will show you maybe how to identify main topic in a text. So for example, here you can just simply copy paste your text to any of these large language model. Or you can first split your data set into several subsets, subset 1, subset 2, and then you copy paste all the text in subset 1, and for example in ChatGPT, and ask it to give you. So you can say, okay, can you please tell me what are the main topics discussed in this text? So very simple prompt. And then again, you copy paste, so it will produce you a topic list, right? So here are the 5 topics that discussed in this text. But this is not enough because you need to make sure that, okay, your result can be replicated across different large language model. So again, you need to do this analysis with another large language model. So apart from ChatGPT, you also need to use, for example, Gemini to do the analysis again, and then to compare different large language model whether you obtain the same topic list. And again, you can repeat this process for subset 2 and compare again the similarity of the topic list. And eventually, you can decide the final topic list. If one topic is always there across different subsets, across different large language model, then you can be confident, okay, then this is really the topic in that text. Okay. And also we can do use API to label the text as well. For example, if you want to do text annotation, then you need to obtain an API key. You need to prepare a training set, and then you need to use a script. And also you need to perform the automatic labeling. So it sounds a little bit abstract here. So to make it easier for you to understand, I will show you directly, okay? So if you have any question, you can also let me know. Okay, so here is the website that we are actually promoting now. So it's a website for you to know how to use generative AI for your research. So we provide very nice, for example, news. So here talk about how generative AI is redefining consumer research. We provide a number of toolkits that you can use. For example, if you want to do text analytics, so which tool you need to use. So we show it here. So it is a map for you, for you to match a certain tool that you can use for certain tasks. So like search engine, literature management, human research, content generation, etc. Okay, but here I want to show you the resources. So if you want to do automatic content analysis, then you can use these two syntax or script. So for example, if you want to use ChatGPT to do the text annotation, then you can click here. So you will be redirected to a Google Colab. So in this case, everything is already there. So you just need to replace. So here you can upload your document. So for example, you just upload your document here. Let me show it to you. So here I use a document that I always use. So it's a Starbucks comment. So you just upload it here. Okay, so Starbucks comment. And then you click here, install the package. So install all the necessary package that you need here. And then you need to insert your API key here. So everyone has a different API keys, and this API keys, it is somehow you can see you need to pay for it because if you're going to use OpenAI's API, it's not for free. You always need to pay for it. But of course, you also have free service. For example, Gemini provides some free token for you to use, of course. So you need to get your API key from OpenAI and paste it here. And then you can click run, and then it will automatically run the text analytics. So what you can change, of course, here is just to do the text analytics using this data set, and also you can see the task here. You see, you are now a researcher and you will tell me if a person who wrote this message is happy or not. Answer either yes or no. So this is the prompt trying to classify this tweet or this Starbucks comment, whether it is a happy customer or an angry customer, right? So of course you can replace it with different prompts. So if you are going to talk about sustainability, then you will replace this command with tell me if the tweet is about sustainability or not. Only return sustainability or none with sustainability, right? So you can always adapt this prompt based on your research question, okay? And of course, you can also change a little bit. For example, GPT-4 here is now using GPT-4, but if you're not happy with GPT-4, you can change to GPT-4o or GPT-4.1, right? So it's very easy to adapt. Okay, so that's the first method. But if you find it still a little bit difficult, then I will really show you the very easy one that you can use immediately. But first you need to have Gemini, and then you need to have use Google Sheet. Okay, and I'm not sure if UK already have this service, but for me it is I use a VPN, and this VPN go redirected to US, so it's very easy to use. So okay, so open your Google Sheet and then upload, for example, your document. So this is your document, right? So for example, in this Google Starbucks comment, then you can see people are talking about Starbucks. You can see Amber and Ladonna at Starbucks something are very warm and welcoming. Okay, now I want to determine whether this comment is positive about Starbucks or not. So what can I do? I will create a new column, maybe about call it sentiment. And here is how I'm going to write the function. So I will just do this and then put AI and then insert my prompt. So my prompt will be tell me if the comment is positive about Starbucks or not. Return yes, return positive or negative or neutral. Okay, so this is the prompt, right? And then you will select this line. It's like Excel, right? Very similar to Excel. Then you will select this cell and then finish. And now you will have this sentiment. So I will drag this function to every cell, so across all this this comment, and then here I can generate and insert. So now it will start to generate positive, 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 neutral, positive, negative, 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 negative. So it's really straightforward, very easy to use, right? But of course, if your data is very sensitive, you are not feel comfortable with uploading to Google Sheet or using ChatGPT, there is still another possibility that if you go back to my website, then there are automatic content analysis using Zephyr 7b. So you can see Zephyr 7b is actually a syntax that is a model that is actually open access. So which means that you will first download this model and install it in Google Colab first. And in this case, all your data will not go through OpenAI or go through Google Gemini. They will only go through the model you downloaded and install it in this environment. So in this case, you can make sure that you will not have privacy problem. So if you are interested in, you can also take a look here. Okay, so if you're going to handle very sensitive data that you are not comfortable with, then you should use offline model, install this kind of model in your own environment and run it there. And this is a 7 billion parameters model, which not really advanced, but if you're going to analyze very simple text, then it should be sufficient to do that. Okay, and if you're going to do topic modeling, I will also advise you to use Google Gemini. So because it supports 2.5, a 2 million token, so you can really input a large volume of text. And if you don't want to pay for it, because Gemini is not for free, then I will suggest you to use AI Studio. So AI Studio is actually from Google, but it is not for consumer use. It's more for developer, and it's totally for free. So you can sit here, try Gemini, so you can do a lot of things with it. For example, you can select the most advanced now model 2.5 Pro preview from just 2 days ago, and then you can select the temperature. Remember the temperature that I mentioned earlier. If you have high temperature, that means the response will be very creative, less consistent. If you have low temperature, then it will be more consistent, and you can do a lot of things with it, and you can test again using different prompt, and then do the topic modeling here using AI Studio. Okay, clear? Any questions so far?
There is one question in the chat.
Okay, let me check.
What counts as a token? Any word?
Sorry, what is the token? What does it mean by a token?
What counts as a token?
Yeah, a token is actually the minimum unit of it. It is a little bit abstract, right? It is not really a word. So maybe open, these words contain maybe several tokens. So maybe 2 or 3 token. So token is really the vector, the minimum unit to calculate, to do the analysis. Okay, so it's a little bit abstract. You don't need to understand that. You just consider, okay, maybe you can imagine it as a word, but it is not actually a word because a word can be several token. For example, if you want to analyze a picture, we know a picture actually consists of many pixels, right? A lot of pixels. So you can consider one pixel as a token. Okay, so token, it can be used for text, it can be used for audio, it can be used for video. So it is the minimum unit for the computer to compute. Okay.
Thank you.
Okay, so that's it for the text analytics. And now I'm going to move to actually today's, the focus of today, which is synthetic data. So synthetic data is now actually a booming topic, a very interesting topic that many, you can see leading journals, they are very interested in this topic. So if you take a look of the recent special issue, call for special issue, the special issue call for papers from IJRM, International Journal of Research in Marketing, they really have a special issue about synthetic data. So it's a artificially generated data that mimics the statistical patterns of real data set without relying on actual individual records. And with the technology of large language model, GANs, VAEs, agent-based model, we can actually simulate or generate this kind of data in a large scale that very similar to human pattern. So what is the use of it? First, it can help us to protect privacy. If you're going to really study people who are, value their privacy a lot and they don't want to share their data, you can use this kind of synthetic data to generate similar impact. So for example, if your data set, you want to have a lot of people to analyze your data set, but you don't want this data set to be openly accessible, then you can use this data set to produce other data set, to generate fake data set based on the real data set. So in this case, you can use the generated data set for other people to use, right? And you don't have the problem of privacy. Or if you want to really investigate a research question that you don't have the possibility to access those respondents. So, for example, if you want to conduct a large-scale experiment with people from all over the world, with people from maybe more than 60 countries. So traditionally, we need to have, recruit people from all these 60 countries. So it's very costly. It's not even possible with language barrier and things like that. But now I can just ask large language model to simulate behavior of people from that country, right? And then to see how they behave across different countries. So that is actually some use cases of this thing. Like you can see it here, augment real marketing data, or create realistic virtual population for behavioral or policy simulation. But here comes the problem, right? So for example, because you use this kind of model to generate behavior pattern, from another population. So you will have probably bias amplification. If your model already have a certain bias towards a certain population, ask it to generate a data set. It can help to increase the bias. Or if your data set, if your model doesn't actually contain any information about that small group, if you really want to study minority and your model doesn't have really any information about that minority, then you will have misrepresentation. Okay, so these are also some problem, and but it is still quite promising because you can enhance privacy compliance and increase data set size and diversity cost effectively, right? So still you can see many scholars are still very positive about this synthetic data, but it's a very controversial topic at this moment. Some scholars are very against to this idea. They believe, okay, you use you use generative AI model to simulate human behavior. That is not really represent the reality. In reality, humans are very complex. We make decisions, based on emotion, things like that. So they believe that we can never use large language model to simulate human behavior. But then you have also other scholars that are really positive about that. They believe that, of course, you cannot use it in every circumstances, right? But you can use it in certain scenarios or certain situations when we really have difficulty in accessing those population, or if you want to study very macro behavior instead of micro, human behavior, right? Individual human behavior. We want to use group behavior. Then in this case, maybe synthetic data can be very useful. So I will show you certain papers. So there is one paper actually now just coming out several days ago from Journal of Consumer Research, and it is the first paper published at leading journal, marketing journal, that use synthetic data for their first experiment. So in their study, they have 6 experiments plus 1 simulation from ChatGPT, and they all replicate the same findings. So it's very interesting. So it provides us some inspiration. Maybe in the future, we can use large language model to do the first experiment and to see maybe our stimuli are effective it passed the manipulation check and things like that. And only if we pass it, then we can replicate it with real human. Then it somehow save our cost, right? So, and the second paper is from marketing science. And also there's some working paper nowadays coming out about synthetic data. And they all show actually very similar result with human subjects. So that somehow is a little bit scary, but it's also somehow quite interesting for us. If you want to use this kind of synthetic data, will it be reliable or not, right? Okay, so I will share you one of our study. So it's together with my student at University of Virginia. So we want to understand whether we can prompt large language model to simulate global value orientation. So for example, if we ask ChatGPT to pretend you are a Chinese, well, ChatGPT, the answer from ChatGPT be similar with people from China or not? So can we prompt our large language model to behave like a person from that country or not? Right. So that is actually our research question. So we know that people from different cultural background display very distinct different preference, norms, values, and behaviors. And now we want to use large language model to generate synthetic data and then to see whether the result from the synthetic data similar to the real result from the human from that country. Okay, and we used already the real data set from the globe study. Probably you know it already. So it's a project conducted in Wharton School of Business. So it is about how people from over 60 countries, their score in certain cultural orientation. For example, uncertainty avoidance, individualism, power distance, egalitarianism, things like that. So there are a lot of different dimensions to measure one's cultural orientation. And we want to prompt the large language model by using the survey they use to get those score. And then we compare the score generated by large language model and against the real score from the globe study. And yeah, here is some literature review. So I will pass it. So here I will show you a very interesting study that is somehow relevant to this study. So it's a study published at PNAS Nessus. So they found out, so they tried to map large language models' cultural orientation against the existing cultural orientation of people from all over the world. So for example, you can see ChatGPT 3, GPT-4, GPT-4o. So if you can see here, you can find a pattern, right? So the pattern is the cultural orientation of this large language model. They are very similar to the cultural orientation of people from where? From Denmark, from Norway, from Finland, from France, from Canada. So they are very similar with people from the West. And they are very different from people from, for example, Asia, from Africa, from Eastern Europe, for example, right? So here is the bias, okay, because they use mostly European or Western data set to train the model. In this case, their cultural orientation also very similar to people from the West. So here, this is the literature, the previous literature. They unveil this kind of phenomenon. But the research question is, can we prompt the large language model to behave like, for example, people from Kenya, people from Zambia? Is it possible or not? Because we know prompting, right? So prompting is somehow to ask the large language model to concentrate on certain knowledge in their model, concentrate on certain parameters on their model. So prompting serves as a attention mechanism to ask the large language model to pay attention to certain parameter, certain knowledge in the model. So whether prompting can be a good strategy to simulate the human behavior in that country or not. Also, is it possible, is it better if we ask the question in native language? For example, if we want to ask large language model ChatGPT to behave like a Chinese, whether it will be more helpful if we ask the question in Chinese instead of in English, right? It will be more effective or less effective? So this is the second research question. The third research question is that whether it will be more effective if we use a Chinese model instead of a English model. Instead of using ChatGPT, maybe it will be better if I use DeepSeek, a Chinese model. Will it behave more like a Chinese than ChatGPT or not? So here is our research questions. And how we do it? So first we select four countries: China, United States, United Kingdom, and France. Okay, and of course, and also the average in English-speaking country as a control group. So together we have 5 countries. And then we select 4 models. So the first model is ChatGPT-4, GPT-4, GPT-4o, Mistral, which is a French model. So it's a model developed by a group of scholars, scientists from France. And E, which is also a similar model developed by a Chinese scientist. And we also use 4 cultural dimensions from the GWOP study. So namely uncertainty avoidance, egalitarianism, in-group collectivism, and power distance. So each large language model was prompted to respond as the average consumer of the target country and answer 18 cultural practice questions. And the prompts were delivered in both English, Chinese, and French. And with each language model country combination answering each question 100 times. Because we need to do some bootstrapping, right? You cannot just ask the question one time. You need to ask the question multiple times and take the average to make sure that you have consistent result. And here's the result we can see actually. So here is uncertainty avoidance. I just use it as an example. So here's the real consumer human score. So you can see China score very high, US score very low. So you can see this pattern. And interestingly, you can see GPT-4, GPT-4o display very, very similar pattern. Even though it's not exactly the same, but you can see the pattern is very similar. But then if you take a look at Mistral and E, they're not really good, right? It's not really similar. So the analysis revealed that systematic bias across different models with significant deviation from GWOP benchmark. However, we can still see very similar pattern, even though they're not exactly the same, but they display very similar pattern. So apart from uncertainty avoidance, we can see in-group collectivism. So if you take a look at the real score from the GWOP, it's super high in China, and then for US, UK, France, they are quite similar. And if we take a look of the result from GPT-4 and GPT-4o, again, it's quite similar, right? But then E and Mistral, they're less accurate. Again, egalitarianism. The real score, China super low, UK super high. And if we take a look of the simulation from GPT-4, yeah, it's quite similar. But you can see there, the overall pattern are similar, but there is deviation of the predicted result and actual result. So maybe we can see, okay, maybe the slope are quite similar, but the intercept are different. The constant is different. And if we do a regression analysis, then we can see actually, so here the dependent variable is the deviation of the real score against the predicted score. So if the DV is very high, that means the prediction is not accurate. And if the score is very low, that means the prediction is very accurate. Okay, so we can see China, if we try to predict China, then we can see actually it's not very successful. Then we can see there is an increase of deviation. So, and if we try to use English, then it reduces the deviation. And if we ask it in Chinese, then it increase the deviation. And if we use Chinese model, it increase deviation. Okay, but there is not a lot of significant interaction effect. That means it really not depends on the model or depends on the language. In general, if you try to ask it in Chinese, then the performance will be reduced. It doesn't really depending on whether you try to ask it to pretend it is a Chinese or not. It doesn't matter. No matter which country you ask it to prompt it or pretend it, using Chinese will reduce the performance of the prediction. But if you use English, it can reduce the deviation, that it will increase the performance. Okay, again, if you try to predict Chinese behavior, the behavior of Chinese consumer, then it will increase the deviation, which means it is not very accurate to predict Chinese. But it is okay to predict, for example, British or US, right? So it is okay to ask it to pretend it's a American or British, but it's not okay to ask it to pretend it is a Chinese. Okay, and we can also see the large language model. So using E has the highest deviation, which means that ChatGPT 4 and ChatGPT 4o are okay. But if you use E, then it increases the deviation. So it's very interesting result. So the result means that it is not true if we want to study a Chinese, then we use a Chinese model. No, it depends more about the model performance. So in our traditional understanding, we know that GPT-4, GPT-4o still are the best model, right, in prediction. So in this case, it still performs better than a Chinese model in predicting Chinese. Okay, and no matter which country you're going to predict, using English is always the best because maybe the original data set is already in English. So ask in another language maybe can distort the original meaning and make the prediction less accurate. So in the end, we can still see, okay, because the fact that when they train this model, they use Western data set. So it is still not very reliable to ask it to predict Chinese behavior or French behavior, and still the best if you ask it to in English because that is the original language of the data set. So that is actually our finding. So you can see the conclusion and implication. So English prompts still minimize cultural misalignment, while Chinese prompt often inflate it across multiple dimensions. And you can see large language models still struggle in reflecting or simulating the cultural behavior of people from certain group. But we can see it can simulate very general pattern, but not very accurate. Okay, so the overall pattern probably is accurate, but not a very specific score. So in practice, maybe it is okay for a company to use this kind of large language model to do some pretest of some, for example, if we want to test the effectiveness of certain advertisement, maybe it's okay, but not replace marketing research or consumer research cross-culturally, right? That is not okay. And we still see very significant model bias, right? Still because all the model nowadays still use Western model to train their model, Western data set to train their model. So still not, they still see very strong stereotypes or strong bias against a certain, opinion or a certain questions. Okay, so that's it for my
There's
today's
questions.
Yeah.
Questions yet, Shubin. So first the questions.
I will stop sharing
When LLM can learn from humans, say this week AI's reply cannot be seen as a reply from country A, Maybe it is possible to pretend from country A next week. My question, how to conduct a study when it could be changed with a day and without being noticed?
That's a very, very good question. And nowadays it's still a little bit difficult because if we use ChatGPT, for example, we use their API. If they update the API, update their model, you will use the new model automatically, right? You cannot select, okay, I just want to use ChatGPT model on in June last year. It is not possible, but there is a solution. You will not use directly ChatGPT API, but you will use Azure from Microsoft. So I will send it to you. So if you use this service, then you can specify, okay, I want to use GPT 4.0 from maybe last year, September. So you can really specify the day. So in this case, even the model get updated, you will still obtain the same result. Okay, so I hope this helps.
Thank you.
And
The
yeah,
next question, can I download Zapier to my own PC in the same way as I have
yes,
with
it's
Llama?
possible. Yeah, so you can download Zapier to your own PC. If your PC is strong enough, fast enough, then powerful enough, then you can perform the analysis directly at your PC. So you can also do it with Llama or Mistral or Q1, which is now the best open model.
Thank you. What recommendations would you have for analyzing data sets in multiple languages, including subjects from different cultures?
It is a very nice question. There is a paper from PNAS. I will show you PNAS, and then it talk about multi-language. So you just select multi-language PNAS. Then you can get this paper. So they found out actually you can just do the analysis directly. You don't need to translate it into, for example, English or standardize them all in English. You can just keep the original data sets in the original language, and then you do the analysis together using a large language model. And the result is very accurate. So if you need to have a citation, you can just use this one for the citation.
Thank you very much. Well, I had a couple of questions, but I think it's time, so I will email you my questions.
Yeah, sure. Yeah, if you have question, you can always email me or go to my website, or we can have a chat and things like that.
Thank you.
Yeah.
So that brings us the end of today's distinguished lecture. On behalf of my co-host, Dr. Pat Diapordi and Professor Charles Dennis, I'd like to extend our sincere thanks to Dr. Shubin Yu for his thoughtful, provoking, and insightful session on applying computational method in research. Dr. Yu's expertise and forward-looking perspective has not only deepened our understanding of the evolving role of generative AI in research, but also inspired a new avenue for methodological innovation across disciplines. His contribution today has provided us with much to reflect upon and indeed to act upon. We also thank all of you, our audience, for your engagement, questions, and participation. We hope you found the session intellectual and stimulating and professionally enriching. Thank you once again, and we look forward to seeing you at our future event. Thank you.
Thank you very much. Thank you.
Thank
Have
you.
a nice
Bye.
day. Bye.
Thank you. Goodbye.
Bye.
Thank you very much.